Exercise 4B, question 8. This is the final question in the exercise. So they've got a little bit meatier for this. We have a pair of fractions, and we need to show that the first three terms of the expansion are. Okay, so first things first, let's turn the question into index form, as we always do. So if we write that in index form, I've got 3 lots of 4 minus 2x to the minus 1 minus 2 lots of 3 plus 5x to the minus 1. Now, I'm not going to try and do all those expansions in one go, so I'm going to be very careful, and I'm going to do them one at a time, and then I'll pop them back in. So I'm going to start first with 4 minus 2x to the minus 1. Okay, I'm going to leave the 3 off for the moment. When I pop it back and put it all together, I'll do the 3 then. Okay, so it's not starting with a 1, so I'm going to factorise that 4 out. So 4 to the minus 1, 1 minus 2 divided by 4 is a half, so that's x over 2 to the minus 1. So our x for this one is minus x over 2, and n is minus 1. Always a nice one, minus 1. So I've got a quarter, 4 to the minus 1, 1 plus n x plus n minus 1 over 2 factorial minus x over 2 all squared. Now I only want to go up to x squared, which is nice. Of course, if you remember when we've done this one before, the great thing about this is that they cancel out, so you just end up actually left with a 1 at the front of that one, which means I'm going to multiply that out in one go. So I've got a quarter. I've got a quarter plus x over 8. 4 times 2 is 8. Plus, again, all my negatives cancel, x squared over 16. Okay, so just neaten that up. So there's my first expansion done. I'm going to keep that safe, and I'm going to move on and work with my second of the expansions that I need. And my second expansion I need is the 3 plus 5x to the minus 1. Bring the 3 out because it doesn't start with a 1. That's 1 plus 5 thirds of x to the minus 1. So there's my power. There's my x. So this will be another nice one as it's a minus 1 power. I've got a third. 1 plus n x plus n minus 1 over 2 factorial, or just 2, 5x over 3 squared. And again, I'm going to just do this in one, I think, because everything's cancelling pretty nicely. I've got a third minus 5 over 9x plus 25 over 27x squared. Okay, so that's done with those two. Now what I'm going to do is put it all back in. So they called it g of x, so we'll call it g of x. So g of x was 3 lots. It keeps doing that. 3 lots of the first expansion, so that was a quarter plus x over 8 plus x squared over 16 minus 2 lots of, we're going to have to be careful when we multiply that out that we do minus 2, so just watch the signs, of a third minus 5/9 x plus 25 over 27x squared. Now, if you chuck that in your calculator one term at a time, you should come out with a 12th plus 107 over 72x minus 719 over 432x squared as required. If we check back up at the top, Yeah, match that there. In an exam, you could mark on the question that you've checked it and it matches. It will save you some checking time at the end. Find the exact value of g of 0.001. So g of 0.01. That's not asking me to put it in the expansion. It's saying find the exact value. So that means putting it into the function, not the expansion. So I would put 3 over 4 minus 2 lots of 0.01 minus 2 lots of, 2 over 3 plus 5 lots of 0.001. Stick that in your calculator and you will get 0.0980311. Okay, it asked for it to 7 decimals and now wants the percentage error. So I've got this to 7 decimals. Let's put 0.01 into the expansion to get a 12th plus 107 over 72 lots of 0.01, because I want to know what the predicted is. I know what the actual is, now I need the predicted, or the approximated in this case. 432 0.01 squared, and that gives me 0.0980 So again, I've done that to 7 decimals, so they are equivalent. To do percentage error, I need to work out the error. So let's do the bigger, take the smaller. I want percentage error, not percentage change. So I literally just want to know the error. So I'm going to take my 0.098031 minus the 0.0980280 all over the actual value, which was the one ending 311, times it by 100, and I get, and it wants it to, let's have a quick check, 2 significant figures. So 3.2 times 10 to the minus 3%, or if you want to convert that, that's 0.0032%. So a nice accurate prediction to finish on.